Here I want to look at some statements that are variations of the conditional, or they are conditionals, but they're kind of variations from a given conditional. And so we have four different statements called the conditional statement, which is just if P then Q. The converse of that, which is what we'd say if Q then P. An inverse, which is if not P then not Q, and what we call the contrapositive, which is if not Q then not P. Now I could come up with a concrete example of this, something like, P is, I am in G wing and I am at delta. Right, so these are two statements, something like that. I don't know, I am in G wing and I am at delta, but it doesn't matter. So conditional statement, if I am in G wing, then I am at delta. Well, that makes sense, right? I've got to be in G wing to be at delta, right? Or no, I've got to be, well, if I'm in G wing, then I have to be in a bigger set of delta. The converse, however, not necessarily true. If I'm at delta, then I'm in the G wing. Well, there's other places I could be, so that's not necessarily the same, but it is a statement, right? There's nothing wrong with making that statement. The inverse, if I am not in the G wing, then I am not at delta. No, not necessarily. I could be somewhere else. I could be in A wing or something. The contrapositive, if I am not at delta, then I am not in a G wing. Well, that definitely would be true. If I'm off campus somewhere, I can't be in the G wing. It's like being in two places at the same time. So, anyway, just an idea, just some ways you can think about those four statements. But the four statements are the conditional, the converse, the inverse, and the contrapositive. Now let's look at the truth table to see if any of these are equivalent, and if they are, which ones. So let's look at the conditional first of all. We know that a conditional is a conditional is false only when the antecedent is true and the consequent is false. So we want P and Q, we want a true and false combination. That gives us false here, and everything else will be true. Okay. With the converse, I need, again, the antecedent to be true, the consequent to be false. So I look at Q and P. Q has to be true, that's one of these two. P has to be false, that's the third one. That gives us a false value here, and everything else is true. The inverse, again, I need true antecedent, false consequent, and I'm looking at my negations now. So a true, not P, it occurs in 3 and 4. It pairs up with an F here, so that one's false in the third row, and then everything else will be true. And then the contrapositive, again, true followed by a false will result in a false. So I'm looking for a true in the antecedent, that's 2 spots, a false in the consequent, which would be up here in the second row. So that's false, and everything else will be true. Now, as I look at these columns here, notice that the conditional statement and the contrapositive are the same, right? They have the same truth values, making them equivalent, right? So we have, so I'm going to put a star right here and a star right here. Those two are equivalent, so we can say that if P then Q is equivalent to not Q, if not Q, then not P. And that kind of makes sense with the example I have here. If I am in G wing, then I'm at delta. If I am not at delta, then I'm not in the G wing, right? So the contrapositive of a statement where you negate the antecedent and consequent and switch them around, they're always equal, right? A conditional and its contrapositive are always equivalent. The converse and the inverse are also equivalent. If you'll notice, true, true, false, true, 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 false, true, going down. So here I'll put maybe an asterisk and an asterisk on those. So those two are equivalent. We'd say that if Q then P is equivalent to saying not P, if not P then not Q. Again, you have the conditional, or it's not really, it is a conditional, but it's also the converse of the original conditional. So these two are converses of each other. So the converse is equivalent to the inverse, okay? And again, to get that, you negate both and switch them around, right? So it's the same process. Negate them, switch them, negate them, switch them. And that will give you an equivalent conditional statement, okay? Technically, all four of these are conditionals. They're just different conditionals. And the way they relate to each other, if you start with an initial conditional, the other three are called the converse, inverse, and contrapositive, even though in and of themselves they are conditional statements because of the if-then part of them. Okay. So this is very important to know that the conditional and the contrapositive are always equivalent. The converse and the inverse are always equivalent. Now, what's also interesting is if I was dealing with a biconditional, what we would find is that all four of these would be equivalent. Just an interesting side note.